For this next example, we're asked to graph the piecewise function f of x is 4x minus 3 whenever x is greater than 3, and 5x plus 2 whenever x is less than or equal to 3. So I'm going to go ahead and just kind of sketch in a vertical line at 3 because I can see that that's where my domain is splitting. And so whenever x is greater than 3, I want to graph my first piecewise function. Whenever x is less than or equal to 3, I want to graph 5x plus 2, the second piece. So let's examine that second piece first, the left portion first. We've got 5x plus 2 as our second piece. It's going to be the part whenever x is less than or equal to 3, so to the left of our vertical line. To graph that line, we want to go to the intercept of 2, and it's got a slope of 5. Because of my scale, I want to probably make this go by 2's. So 4, 8, 12. And so whenever I'm graphing, I've got the intercept of 2, and I want a slope of 5. So then 1, 7. And then I'm going to go to 2 and 12. And then 3 and 17. And so we can see that we have this line that has a steep slope, and it's graphed on the left side. We don't want to graph it on the right side because we only want this line whenever x is less than or equal to 3. The next piece, the first piece actually, 4x minus 3, is the part that's going to be graphed on the right. If we think about graphing that line, we have an intercept of negative 3, and again I went by 2's on that axis, so I need to make sure I uphold that. And then a slope of 4. So we'd want the point, if we plugged in 1, we get the point 1. And then if we plugged in 2, we get the point 5. And if we plug in the point 3, we have 12 minus 3, which is 9. And then the next point would be 4, and 16 minus 3 is 13. Now if we take a look at the points that I just graphed, we only want the points that are on the right side of that line. So I'm going to erase the bottom points, and I really could just start out by plugging in 3. So 4 times 3 minus 3 gives me 9, and then get one more point, so 4 times 4 minus 3 gives me 13. Connect those points, and we want the points to the right. I'm going to erase my vertical line. And then notice that we have two function values graphed. We've got the point 3, 9 and the point 3, 17. We can only use one of those, otherwise it's not a function. So we go back to our definition and we see that we wanted the line 5x plus 2 whenever x was exactly equal to 3. So that's our left portion. Whenever x is greater than 3, we don't want to include that 3 value. So I'm going to erase that point. And at 3, 9, we want an open circle, and then we connect those dots. So this is our piecewise function.